Hi, and welcome to part 2 of this Build With Me video project. We're building this amazing Technicolor light, come clock, come spectrum analyzer. And if I've done everything correctly, somewhere on screen you'll be seeing a finished version of this. If I haven't done it correctly, you won't see that. But in part 1, we went over the contents of the kit, and then we assembled and soldered up this processor board. That will be linked to somewhere on the screen. In this episode, we're going to move on from this to the main display board. This is kind of enormous. Can't really fit it in. It keeps on going and going and going. It's about a foot wide, or 300 odd millimeters wide. And basically it's a lot of repetitive work. Every one of these is an LED module, one of the WS2816 or something or other like that, RGB digital LED module, and then each one has a little decoupling capacitor as well. So in this episode we're going to be populating this board, and depending on how long that takes, we will then move on to actual assembly of the whole thing into the supplied acrylic case. So we're going to start with actually putting in all of these decoupling capacitors, as they're the smallest component, and it'll be nice just to get them in and out of the road. We'll see if we can get you some close-up shots of the surface mount soldering. I'm using just conventional soldering iron to do this, although you could use solder paste and a hot air soldering station, which may or may not be easier depending on what you've got and what you're used to. But let me reposition the camera and see if we can get some nice close-up shots of this. So we're just going to start off with a more or less overhead view, zoomed in. These are absolutely tiny parts. Here's a millimeter scale. So these are just over a millimeter long. Or if you want inch scale, it's whatever that is. Really small. Don't try and work too close to these because breathing will just blow them away. And if you sneeze, well, you're going to need a lot more parts. So we'll dispense just about the right amount of flux. And then I shall tin my soldering iron. I shall grab hold of this so it doesn't fly off. And that has done that. Very simple. I'm not going to film every single one of these. That would be incredibly boring. But what I will do is I will rearrange the camera position and try and show you a few different angles of doing these. Let's try from another angle. A little bit off to one side there. Alright, so trying to get an extreme close-up, had to use a different camera. And we'll see just how this turns out. Here we go again, another slightly different angle. And there we go. So just have a quick zoom in on these to make sure that they're all right. Looking good. So one thing I've noticed about this is while there are 8 spaces for LEDs, there's only 1, 2, 3, 4, 5, 6, 7 decoupling capacitors. I find that a little interesting. Now before I move on to actually putting the LEDs on, I'm just going to get my multimeter and I'm going to check out that there's no shorts on this, because I've done all these decoupling capacitors. Now is the time to be able to check this. So one moment, I will get my multimeter. So sorry about the funny angle on the meter here, it's just the lights are reflecting off it. So if I just flip this over, we have here DI, which I presume is data in, ground, and VCC. And then sort of mirrored on the other at the bottom, VCC, ground, and then data out. So we want to be testing between ground and VCC. I've got this in continuity mode, and so there's no short there, but as you can see it is linked over. But of course data in isn't linked to data out directly because it goes through all of the chips. Interesting that this possibly could be cascaded onto another display. And one other interesting thing, because we've just put 200 odd 0.1 microfarad capacitors in, we can put this into capacitance mode and we can measure the capacitance, overall capacitance between ground and VCC. When eventually my steam powered multimeter comes to it, here we have 25.2 microfarads. So it's nice that they're all reading that. So now we move on to populating the 256 RGB LEDs. These are LED chips. They are the WS2812. You can see just a little chip with the bond wires coming off, and of course to the different areas here for the different LEDs that are part of this. In fact, they might be RGBW, I'm not sure. But anyway, these are a little bit more tricky to solder in. I show you, here we go, here's the underneath, and you can see that the leads do not extend very far outside the package. They rise up a little bit. So these are ideally suited for solder paste and then reflow oven or hot air gun use. But since that is too easy, we're going to try doing this just with conventional soldering iron. Now of course there is a little corner notch on this. You get it at the right angle, you can see it. And then you can see on the silk screen itself, we've got a little corner notch. So we just have to make sure that these are aligned properly. and then we're good to go. So here goes for the first. We got our notch. Here we go. So much as we've done before, just going to tin the soldering iron, align this as best we can. Just keep using plenty of flux. And there we go. It's just a case of lather, rinse, repeat, as the song doesn't go. There we go. That only took about 1,000,000 years to complete. That's just the residue. Need to give it a bit of a brush off. So the next stage will be just soldering on the wires to this, and then this will be done. Hopefully they gave you some extras. Actually 16.5 extras. So that's very helpful. They can go into the parts bin, assuming that all of these are okay. I haven't tested any of these, so the first time we see whether it works okay will be whenever we wire it up completely. So now I've just got to hook up wires to this end, and that wires in, I think, onto the board here somewhere. Yeah, probably there. And I'll have a check of the instructions, and then we can wire it up and then hook it up and see if it works.